Alright, this time I'll talk about the problem overfencing. So in this problem, we will use basically the same as a simple DFS, but the most difficult part I think in this problem is the implementation, like how you need to identify which blocks you can go to, because this one it isn't just simply which graph is connected to what. You have to read these characters in and then see what path you can get. So here's my code. I use getLine to so this grid I didn't use a character array 2D character array. I just used the string array, because you can also get each characters of the string and it works the same thing. And another reason is because that if you use cin on chart, it will ignore all the spaces. So I just use this get line so I can get all of the characters, including the white space. And first I did a get line for this. This is just because after using the cin, the pointer is still at the first line. It's right here. So I need to use getLine to get it to this line first, and then we can read the input. And here, this loop identifies where the exits are. So I created these two, exit I and exit J. Exit I is it represents which row the exit is at, and J represents which column the exit is at. And I created these and give them an array length of 2 because we know that there are always two exits. So I use this to keep track of which exit we're looking for. And I went through all the edges, so I equals to 1 all the way to h times 2. This is the amount of rows we have. And each time here, notice I added 2 every time because we can skip these lines, the ones with the plus lines, because there are no grids on there. So we just need to look at these vertical lines. So I skip these, and I check if the left side of the wall is empty. If it's empty, then we know that this is an exit, and I added an increment c by 1. Because we know one exit and we have to find the next one. And here, although I used I0 here, I put in 1 as the j, because that is only the wall, sort of the wall, and this is actually the important part. What's on the right of it, so I have to increment it by 1 as well. And then this one checks if it's if there's an exit on the right side of the wall. If there is one, then I also did this, but now I subtract it by 1 because we want the one grid on the left of it. And this is the same thing, but it checks the upward wall and the downward wall. So it's also the same, but I changed the measurements to width instead of height. And now I use DFS on starting at those 2 coordinates. So here this is basically normal DFS. The C is it keeps track of how many steps we're at, and we start at 1 step because it says that each empty block counts as a step. And since we start at an empty block, that will count as a step as well. And first it checks if we're out of range. If any of these cases happen, then that means we're outside the boundary. So that wouldn't happen, and we will return back this function. And or maybe our c is greater than or equal to the distance we've already found. What this means is that in case we've encountered a loop, or it's already bigger than, so because I have 2 DFS here, so maybe after we search through this EI0 and EJ0, maybe that coordinate already has the shortest distance, so we don't need to search it again using the second coordinate. So either of these cases, this function will break, and otherwise we check if we check if this distance is equal to 0 or c is smaller than the distance. This means when distance is equal to 0, this means that we haven't assigned it a distance yet. So we know no matter what, c will be the distance for this coordinate. Or if c is smaller than the distance that we found from previous, then we will set the distance to c. And then this is the part where we use the recursion to check each of the directions. This first direction checks if we can go up. So it will look up one square, and if we cannot go up, we will encounter a dash like this. But if we can go up, there will be an empty gap like this. So if it's an empty gap, then that means we can go up. But we don't want to be at I-1 because that's the row that's about walls. So we want to go up one more step to get to the empty space. So we use DFS on that with an extra step. And this checks if we can go to the left. Also the same thing, if it's an empty space, then we can go 2 steps to the left, but like two grid to the left, but then it's actually just 1 step. And we also check if we can go down or not, and we check if we can go to the right or not. So this will run until it stops, and then we will use DFS again, but this time we start at a second exit. So what this does, it will loop through, it will go to all the coordinates and replace the ones that this one's shorter. So like for example, for example this grid, if we want to go to this place, then we know that there will only take 2 steps if we start at this exit, but it will take a lot of more steps if we start at this exit. So we will use DFS on both of the exits and see which one has the shorter length for each coordinate. And then finally, I use this. So every time here, I store the distance in this array. And finally, I have this answer variable. And first, it starts off as 0. And now I also go through each of the grids. And I also skip 2 every time here, because as I said, each of like every other row and column of this grid is a wall, so you can skip that line, and then it checks which one's greater, and we will find the greatest distance, and finally we'll print it out. And that's it for this question.